So today, wrap up power and beta and talk about sample size. Now, let's find out if any of you happen to have any questions regarding any of those power and beta problems that were in top class. There were a total of, I believe, 11 problems. And I provided you with answers to each one of those. And I'm willing to spend some time here in class going over any of those problems that you'd like me to deal with. Any one of them. Any one of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11. Any one of them. Or not. Going once.
Number one, let's do one together.
Number one?
Could we do one together, please?
Okay, which one?
Number one.
Number one. Number one. Okay. Let's take a look at it. Number one. Number one, by the way, for all of these problems, seeing if there are any exceptions. I don't, looks like there's one which is for a two-tailed test, but they look like the alternative is for greater than, if I'm looking at the right sheet. And that's different from the ones that we worked out in class last week. I wanted specifically for you to have some experience dealing with problems where the alternate happens to be the other direction instead of less than. And we'll see how that happens to go. I give you the mean, and that's for the hypothesized. The mean for the first one is equal to 50 versus an alternative that it's greater than 50. The alpha level happens to be 0.05. We have 100 subjects involved. The standard deviation is equal to 20. And the true mean is equal to 52. Let's see if we can take all of that information and find out that power is equal to 0.260 and beta is equal to 0.740. So I've given you all of that, and sometimes it's a problem if you look at the answer before you try to work it out. So I'm hopeful that all of you didn't cheat and look to see what the answer was, but that you worked it out and you found out if your answer happened to be the same as the one that I supplied for you. Okay, let's do this first one. We're going to start with the hypothesized distribution. So this is HO. Mean of the means is equal to 50. The standard error of the mean, I'm going to stick this up here so it's out of the way of the other one. Standard error of the mean is equal to 20 divided by the square root of 100. Or it's equal to 2. It's a one-tailed test. The alpha level happens to be 0.05. So since I don't have all of this information, you're going to have to kind of help me here. I want to find out what that critical region happens to be. And that's going to be the z-score, 1.645 multiplied times 2, and then we add that to 50. And what did someone who has done this problem come out with as far as the critical region? 53.29. 53.29, all right. We will trust you to have computed the correct answer, at least this part. Okay, now, right next to that, we're going to be the sampling distribution for the true. It's like, what if the true mean happens to be equal to 52? What if the true mean is equal to 52? And we know where to locate that because we've established that the critical region is at 53.29. So the top part of this true curve is going to be about right there. It's going to be a little bit to the left of 53.29 since it's 52. So let's make it about like this. And we'll label this as being true. This is the true. And this mean of the means is equal to 52. Okay, now I'm going to extend this line in the true distribution for the critical region and the hypothesized. So it's going to go straight up like this. And as I look at these two distributions, when we determine both power and beta, the areas are going to be found in the true distribution. That's a given. The area that is associated with a rejection of the null hypothesis, that the mean is equal to 50, will be one where the value of the statistic must be 53.29 or greater to result in rejection. Correct? If we reject a null hypothesis that's false, what I just gave you is the definition for what? Rejecting a null hypothesis which is false is what?
That's one, right?
I'm sorry?
That's one, error one.
No. That's rejecting a null hypothesis which is true. That's a type 1. Rejecting a null hypothesis which is false is power. And I brought along the two colors. And the color red is supposed to represent power. So from 53.29 on up in this true distribution, that's the area that I'm going to shade in red. And so I've identified now the power area. And then that area, which is associated with failing to reject a null hypothesis which is false. What's that the definition of? If we fail to reject a null hypothesis which is false, what is that?
Error 1.
What is it?
Error 1.
No, that's
2.
Yes. Boy,
Right, you got it.
obviously you people ate too much turkey. You're not into that statistical mode yet, thinking. Failing to reject a null hypothesis is associated with a type 2. Failing to reject a null hypothesis, which is false, rather, is type 2. So let's go back again, and I'm going to shade in the area for type 2 in green. And again, now this is going to be in the true. Yes, type 2 is beta. So type 2 error and a beta error, they're identical. So I'm going to label these now. This is power. And this area over here is beta. Okay, how are we doing so far? Do you have any questions? Any particular problems? Because from this point, it's like a piece of cake, right? All we have to do is compute some z-scores, and then we're going to be looking in the table, the z-table, and establish what the areas happen to be. And by now, going to that z-table and determining the larger area and the smaller area should be pretty easy. Should almost be an automatic. Okay, let's find out what those values are. We're going to be computing a z-score for this 53.29 and in this true distribution. So our z-score for this point right here is going to be 53.29 minus 52, and that's divided by 2. And what do we have now for a z-score? It's a minus 0.645. Okay, thanks. Minus 0.645. I'm sorry, you're right. That's right. Yeah. Okay, you're right. All right, so we've got a z-score, which is 0.645. We don't find that value in our table, so I guess we can round that off to 0.65, or I guess you can split the difference. I don't know for sure what the answer came out. But for the area that's associated with power, that's going to be the smaller area. And if we go to the table, we should find then that power is 0.260. And if we subtract that from 1, we will find that beta is equal to 0.740. If we go to the table and look for a z-score of 0.64 and look for the smaller area, that's going to be the area associated with power. And then the larger area, the green area that's up there, will be associated with beta. And those two must add up to 1. So power is equal to 0.260. Beta is equal to 0.740. And those two do add up to 1. So if for the final exam I had 10 or 15 problems that were power and beta, be good? Everybody's applauding here in Lincoln. Yes, yes. Well, that will not be the case. However, there will be several problems on the test which will deal with that. And would you like me to give you some idea of what the exam information will be? Okay, before the class is over with today, I will share with you a breakdown of what the number of items will be on the third examination, the final examination for the class. Rashida, do you have any questions about number 1?
I was just wondering about the way we calculated the first one.
What
We did the standard error, and then we found the z-score. How did we get that?
The standard error is the same way as we've figured it before. We just have the standard deviation for the sample divided by the square root of the sample size.
Yeah, multiplied by z plus 50.
Whoa. Not
That's
sure.
what
The value, for this value right here,
Yeah.
okay, that value was found by multiplying 2 times 1.645, which is the z-score that goes along with 0.05.
Oh,
0.05,
Oh,
right?
okay.
And then adding 50 to it. That's how we come up then with 53.29. Okay? Any other questions for this first one or for any of the others? So you've all done all of these problems, and it's as clear as can be. Crystal clear. Clear as the mountain water in the Rocky Mountains out there, right? Okay. I gave you a chance.